What you get?
So, good morning, everybody.
Good morning.
Yes?
So I had a question on the
Okay, yes. We'll be getting back to our regular class business in a little bit, but as I promised, we do have a special guest today. As you notice, there's someone unfamiliar in the room. So we will continue our final review and everything else that we have to attend to in a little bit, but I don't, do you all know Sabrina? Sabrina Liu here? Sabrina is a senior. She was in my class in the 8th grade in Honors Algebra 2, and stellar every time. And some things that you may not know about her, she's very accomplished piano player, accomplished flute player, a flautist, pianist, and an amazing mathematician. But one thing a lot of people, even her friends, I imagine your friends don't even know, is that she's accomplished at special tool. And I'll let her introduce it and herself and whatever she said. But I'd like to give the floor over to one and only Sabrina.
Thank you. Hi, I'm Sabrina. Just received the best blazing session of my morning. So today I'm gonna talk about, is that working? The abacus, which is this little beaded tool. I'm Mr. Lieberman in 8th grade, and we had a class on this on Zoom, which was very interesting. So this little beaded instrument, it can help you learn like mental math, or it's just like your little personal calculator without any electronics or batteries. So this is called the abacus, plural abaci or abacuses. And before we get started, Mr. Lieberman, do you want to do a quick demo?
Oh, sure.
So just like give me like numbers, and I'll just add them up.
Okay, how many digits?
You can do like 3.
3 digits. And how many numbers would you like?
What do you guys say? 10?
You want 10 3-digit numbers?
Whatever's fine to do.
Okay.
Do you have a calculator?
I don't. Do you mind?
Yeah.
Should they use a calculator?
Sure.
Okay. So let's see. So 10 3-digit numbers.
Or like just how many you want. You don't have to count them. You can do like 8 or like whatever.
Let's see. 762, 419, 358, 511, 921, 203, and 616.
3,790.
Yeah, perfect.
Okay, so that is basically what this is. And the cool thing about this is if you like practice enough, and you translate this into your head, you can do this, whatever is happening on here in your head, so you can basically do like mental arithmetic or mental math. You wanna give me like a few 2-digit numbers?
Sure. 75, 63, 15, 44, 83, 93, 10, 24, 76, 35, 93, 27.
638.
Perfect.
The 10 threw me off, but I still got it. So yeah, that is basically what this is. And before I kind of get into the mechanics or composition of this, I'm going to do a quick little history. So you can see like the abacus in all of ancient history. There are different forms. Like you can see some of them with like 2 beads on top, some of them with like 5 beads on the bottom. There's all different kinds of abacuses. They're pretty much widely used throughout all of history before the whole world adopted the Arabic numeral system, which is like 1, 2, 3, 4, 5. And even in Mesopotamia, like the abacus appeared in Sumer in like 2700 BC, which is insane. Like that's like 3,000 years before Jesus was born, or whatever month, year you go by. And they're in like ancient Egypt, Persia, Greece, Rome. It's pretty interesting that Native Americans also have them, which I find pretty cool because they're like halfway across the globe, but they developed their own like beaded system. So this kind of specific abacus is called the Soroban. It's Japanese. I'm probably not pronouncing it right. Sorry, I'm not Japanese, but it originated from the ancient Chinese abacus. But in the 1300s, the Japanese started to modify it and make it like their own. So there are always an odd number of columns or rods. Usually there's 13, but sometimes you'll see less or more. This top part is called, this represents a 5. This is called a godama, and it has a value of 5. And this bottom one has a value of 1. It's called an ichigama, so like 4 of these would be 4. And the beads of each rod are divided by this thing, which is called a reckoning bar, and each rod represents the digit. So for example, this is 1, and this would be 11, 111, 1,111. Sorry, let me change that. This one is pretty dirty. And this one's also missing a bead, but this one is something I've been using since I was 4, so it has like a lot of sentimental value. There's like mysterious stains, and it's like all like taped together. This one is more new, so I'm gonna use that one. So again, each rod is a digit. This is a 5 on top, and this is each one on the bottom is a 1. And a unique feature that separates the Soroban from other abacuses is that every 3 rods there's a unit. So like this would be 1, this would be 1,000, this would be 1,000,000, and then this after the 1 would be like decimal places. So this would be 1,000ths. And yeah, so again, moving beads toward the reckoning bar is like the on position. So if you move the bottom one towards the reckoning bar, you have 1, and then if you move the top one towards the reckoning bar, you have 5. And just more on that counting later, but the form of the abacus is usually through this, and then you just like clear it, and that gives you 0. So like let's just say I do like whatever, I mess it up, is my answer, and then if I want to redo a problem, I just do that. If you're Mr. Lieberman, then you have like this cool contraption where you can cheat and you don't have to clean it. You can just, I can mess it up, and you can just do this, this little contraption. I don't think these are like allowed at competitions.
Oh really?
I'm not sure, because I haven't been to like a competition in like 7 years, but last time I went, these were not allowed. But they might have changed now, they could be allowed, but I've never changed to like this contraption because, I don't know, just resetting a problem, doing this thing is kind of, resetting a problem, doing this thing is kind of like, it like clears your mind, and it feels satisfying. But I understand why some of you may want to do this, like, especially like a lot of Asian countries still use abacuses like on like the streets for like, let's just say like a food booth or something, and they still use abacuses, so it could be much easier just doing that. But yeah, that's a pretty cool contraption. So, quick thing, so Americans usually count like 1, 2, 3, 4, 5, right? Like this is 5, this is 10, that's about it. You want to count your toes, and you can only go up to 20. Everyone has different ways of counting. Like if you guys have watched like Inglourious Bastards in Germany or in Western Europe, they count like this. Ancient Egyptians used to count by their joints, so they would actually have 12 per hand. If you're gonna use the Soroban, then you have to count like, it's still 1, 2, 3, 4, but for 5, you change to your thumb. So a thumbs up is a 5, so it's 1, 2, 3, 4, 5, and then this would be a 6, and then 7, 8, 9, 10. So this is 1, this is 5, and this is 10. This is 10, this is 5, this is 10. So you can go up to like 11, 12, 13, 14, and then for 15, you go up to the thumbs up again. 16, 17, 18, 19, 20, this would be 25, 30, and then 45, 55, 65, 75, 85, 95, this would be 99. So with this system, you can count up to 99 for hands, while with the American system this is just 10. 99, and then you want to go more, then this, like you would just put 100 in your head. So this, if I have 1 in my head, then this would be like 119 or like 115, 117, like that. So if we translate that to the abacus or the Soroban, so this is still my 1, so that's 1 bead, 2, that's 2 beads, 3, that's 3 beads, 4, that's 4 beads. But since my 5 is a thumbs up, then I would just go up to 5. And then since this is my 6, it's just your thumb plus 1 of your fingers, and that's just 6. And then 7 is your thumb plus 2 of your fingers, so that would be 7. 9 would be like this, so that's your thumb plus 4 of your fingers, and that would be like this. Yeah, so I think this is called like the biquinary system. Bi, because there's 2 sets, and then quinary because it goes by 5s, because this is your thumbs up is your 5. Like if you guys want to change, like I do think this way is way easier to count, just because like by itself you have 99 instead of like 10. So yeah, that is how. So like again, this is 1, 2, 3, 4, and then for 5 you go up, and then that's a 6, and then 7, 8, 9, and then that's a 10. And you can tell that's a 10 because your unit digit is at the dot right here. And then so this would be 15, and then 16, 17, 18, 19, 20, 25, 30. This is like your 39. This is a 40, and 88, and 89, and 95. This would be 100. If I'm losing, guys, just let me know.
Can you talk about the 95 quickly?
Yes.
Let's break it down.
So this unit digit right here, 1 digit, that's a 5, because that's just your thumb, that's just your bead. And then 10's here, that's a 9, because you have a thumb here and you have 4 here, so that would be 5, 6, 7, 8, 9. Yeah, this took me years to learn since I was 4, so this is not something I expect anyone to get in like 10 minutes. That's 95, and then the thing about like the abacus is that's like better than you in your head is you can like keep track of like up to the millions. Like this would be a 165. Let's just say that's a 175. That's a 100. That's a 5, and then 2 of these, so that's a 7, and then that's a 5.
Yeah.
So like, for example, this would be like 123,456,789. So that's just 1, 2, 3, 4, and then 5 is up here, and then 6, 7, 8, 9.
Okay.
Is there anything else you want me to go
No,
over?
that's great. Thank you.
Okay. And so now we can like, once you get that done, you can add numbers. So how you add numbers, let's just say I want to add 75 plus 12. That would be easy, because plus 12, oh, the thing about abacus is I know like in elementary school we learn to add from the right to left, but with the abacus you add from left to right. So and to add 12, you first add the 10, and then you add the 12. That's easy, that's in 87. But let's just say you want to add something that is bigger than 12, or that would make you go into the hundreds. How do you do that? So let's say, well, let's just say we want to add like 68. So we have to first add the 60. There's only 1, 2, 3, 4, 5 beads here. How do you like add a 6 if you don't have that many beads? Well, it's like the same system of carrying over 10. So what does 10 minus 6 equal?
4.
4, right. So what you do is you first subtract 4 from this. That would be a 3. And then you add a 10 here. So now it's 13. Not 13, 130. And 70 plus 60 is 130. We still have the 5 here. So let's just say we want to add 68. So we still have to add an 8. What is 10 minus 8?
2.
2, right? So you just subtract 2 from here, and then you add a 10. So now it's 75 plus 68 equals 143.
And you were doing all that in your head when he was giving you the numbers?
Yes. Yeah, once you get familiarized with this, you can translate it into your head. And it took me about a few years to get familiarized with this. Like, it was not, oh, I'll do it for a few weeks. And the thing about the Soroban that I like versus other abacuses, which I'm not that good at using, this one is, it's very similar to how we were taught to add, just carrying over a 10, or just like, everything is by the 10s or by the 5. It's, some abacuses are by like 7s or 9s or whatever. This is by the 10s and 5s. It's just easy for me to understand. We can try another one like 89 plus, let's just do 89 plus 89. So if we want to add 80 here, but there's not enough 8s, we go back to the system I taught about, I just said about the 10s. So like, what's 10 minus 8? Right, so you minus 2 here, and then you go up to the 10s. And then we want to add 9 here, so what's 10 minus 9?
1.
So you just minus 1 here, and you go up to the 10s. So that's 178. 89 times, plus 89 is also just 89 times 2. And you can also do multiplication and division of this. So let's just say we're going to do 89 times 2. So we would do, so 8, 9, 2, that's 3 digits. What you do is you have 3 digits, you minus 1 digit, you have 2 digits, so you start here, which is two rods. So 2 times 8 is 16, and then 2 times 9 is 18. And you just get the same answer, 178. We can try it with bigger numbers, like,
Can you do that one more time?
yes,
Please.
so 2 times 89, so 2, 8, 9, that's 3 digits in total. We minus 1 digit, so we start at the second, which is 2, so we start at the second rod. So
Do you
it's-
always subtract 1 digit? or
Yes,
is it-
always for multiplication, which is, I don't know how that works, but I've always been doing that. I think there's an official explanation, I can't really tell you this is what I've just been doing. So what's 2 times 8?
16.
16, so you just put 16 here. You move your index to the right, and then so it's 2 times 9.
18.
Right, and then you add 18,
Interesting.
and that's
Oh,
178.
that's actually good.
So we can do like 3 times 89. So let's just do like 3, 8, 9, that's still 3 digits. So you start at the second, you minus 1, start at the second rod. So 3 times 8 is 24, and what's 3 times 9?
27.
Right, so it's like that, 2, 6, 7, which is right. If you want to do like bigger numbers, like 75 times 68.
Ooh.
How many numbers are in there? There's 4, right? So we minus 1, we get 3. We count to the third rod, so we start here. Our index starts here. So 7 times 6, 42. I'm just gonna write this down so you guys can follow me. Okay, so 75 times 68. So we start at the third rod. What's 7 times 6?
42.
Yes, 42. You needed their timetables for this work. And 7 times 8. What's that?
56.
Yes. So now we're done with the first part. So then we go on to what's 5 times 6.
30.
So you add 30 here, and then what's, you move down again, and then what's 5 times 8?
40.
Yes, so then you get 5,100, which is the answer. We can go on.
I'm sorry. That's so cool.
We can go on to bigger numbers, like, let's just do 7, 5, 2 times 6, 8, 9. This is gonna be a big number. I can't do this in my head, but I know some like genius kids who can, and that's not me. But so there are 6 numbers here, so we would start at 5 rods. So this is the fifth rod. 1, 2, 3, 4, 5. 7 times 6 is 42. 7 times 8 is 56. 7 times 9 is 63. 5 times 6 is 30. 5 times 8 is 40. 5 times 9 is 45. 2 times 6, what's that?
12.
Yeah. What's 2 times 8?
16.
And what's 2 times 9?
18.
Yes, so then we get the answer is 518,128. Which I hope is right. What if it's not right?
Wait, say it again?
518,128.
Yeah.
Yeah.
Oh, okay, cool. You can do the same thing with division. I'm not as good as division, just because there's like, I don't really. Division's weird. I'll tell you why. We can start with something easier. Let's just do 6,000. No, let's do 65326. Okay, this one is.
So you chose an easy one.
Yeah.
You'll see later. This one is. It's weird. I'll explain later. But these like numbers that are bigger together, like 8, 9, or 7, 8, or like 6, 7, or 9, 8. Those are easier than numbers like 19 or like 28. That are like the digits that are farther apart. I'll explain later. But so we can start off with 65326. 65326. Now there's no like trick where you can just like add up the numbers -1. You just gotta hope for the best and start somewhere. So let's do 65326. So how many 8s can fit into 65?
8.
Yes. If we do 8, I'm just gonna put down 8 here. If we do 8, that leaves no space for a 9, so we should go down 1 and go to a 7. So that's why I say division's a bit trickier, just because you can't just go for it. You need to consider the next few numbers. So 653, let's do a 7. So 7 times 8 is 56, and then 7 times 9, that digit, is 63. Now to the easy. So how many 8s are in 30?
3.
Yes, so you can put down 3 here. 3 times 8 is 24. 3 times 9 is 27. Now this part's easy because you're left with 356 and you have 89. You just like at the last digit, that's a 6. The last digit there is a 9. You know that 9 times 4 is 36, that is the 6. So you don't need to guess or check, you can just put down 4. So 4 times 8 is 32, and then 4 times 9, 36. And the answer is 734.
Is that right? I imagine it's right.
Yeah. And if you sometimes you can go into like decimals, but
Verified.
in most standard exams they don't ask for decimals, so you don't really need to know decimals. So I
There
never
are
really.
abacus exams.
Yeah, there are abacus exams, and they're like pretty big deal. Like you gotta bring like your birth certificate and like every ID. They don't want cheating. And if you like pass enough exams, you can become you get a certificate and you can become an authorized teacher. I passed all my exams in 5th grade, so which is earlier than usual, but I passed them all, and which meant I didn't even learn anything anymore. But my mom just kept on sending me to my abacus teacher, who is this very nice Taiwanese lady. And so I had nothing to do when I was just sitting there, so she was like, why don't you become my TA? So I became her TA when I was in 5th grade, which is pretty fun. And I got like $1 for every student I taught. So if I got 16 kids that day, I would make minimum wage. If I did, sometimes I just get 2 kids, I just get $2 for 90 minutes, but you know, it's fine. So when I mentioned that it's harder when you have like numbers that are farther apart, it's because, I'll show you guys why. So let's just do So now 2 and 9 is pretty far apart. 9 and 1 is also far apart, but that's okay, because 1 is so small you can pretty much just like, anything works. But 9 is pretty big, and it's pretty far from 2, so not everything will work, and you guys will see why. So if I do 213,594, so 213,594. I'm gonna start here. So technically 9 2s fit into 21, right? 2 times 9 is 18. Honestly, 10 2s fit into 21, but we don't go up to the second digit. The farthest we go up to is 9. So we can put down 9 here, but it's tricky because it won't work, because once you minus 18, you're only left with 33, but 9 times 9 is 81. So you gotta account for the fact that the next number is so big. Does 8 work? 8 also doesn't work. Pretty sad. So let's hope 7 works. And I know that 7 works because you just get used to it. So 7 times 2 is 14. 7 times 7 times 9 is 63. And then 7 times 1 is 7. So you can see how it almost always works with 1, because 1 is so small, you really do not have to account for it. So now, again, how many 2s fit into 9?
4.
4. We can try 4, but if we minus 8, we don't have any space for 36, which is 4 times 9. So we gotta go down, usually you go down 1, sometimes you have to go down 2 or 3. So let's just go down to 3, and that works. So 3 times 2 is 6, and then 3 times 9 is 27, 3 times 1 is 3. Now you're left with 1,164, and that is pretty easy because 1 times 4 is 4. You're left with a 4, so you can just put down 4 here, and you don't need to check it. So 4 times 2 is 8, 4 times 9 is 36, 4 times 1 is, so the answer is 734. Yeah.
What?
Yeah. So I think now I'm gonna use this one. I'm not used to that one. This one is still something I've been using since I was like a little kid, so I like this one better. So I want everyone to like think of a 3-digit number and have it in your head.
Okay.
Are we all good? Do you all have a 3-digit number in your head? And let's just go in this order and say it out loud. And I'll try to add them up. I must say, like, my ADKI skills, this thing itself, is pretty rusty, because I'm used to teaching, like, as a TA, I'm used to teaching kids the basics of, like, 5 + 7 = 12, or with your hands, and I haven't used this in a long time, but I started using this last night to prepare for this. But yeah, let's just all think of a 3-digit number, have that in your head, and then that way, so when I ask and go around, you guys can say immediately, because it's honestly harder for the person doing it when it takes longer to say it out loud. Like when it stalls, it's kind of hard to like keep everything in your brain. But okay, so you can just call them one by one, and I'll.
Let's get an order here.
Okay.
Dylan, we'll start with you, and then we'll just kind of go this way until Ava. Does that make sense? And I'm not gonna give a number.
Okay. You can give one if you want.
Okay, then I'll go after you.
Okay.
So, we're starting with Dylan. Everyone understands the order? You have your number?
Yeah.
Okay.
Okay, cool. Whenever you're ready.
1 to 28.
1 to 28.
4, 6, 8.
Fast.
Sorry, I can't hear you.
123.
Okay.
335. 204. 779.
816.
324. 638.
173.
632, sorry.
100.
899. 285.
5904.
I didn't type in fast
Who
enough,
said-
so. What was your number?
Who said 638?
173.
173.
I did.
Okay.
So that's a lot of pressure.
What was your number?
602.
Jana, what was your number?
I think it's 899.
What was it?
899.
Yeah, I think so.
385.
You said the answer was what?
5904.
Huh?
5904.
Well,
Maybe.
it's here it says 5880, but I'm gonna trust your advocacy.
Yeah.
No, it's like
Probably
I'm not
don't
always
trust
right.
me.
I wonder if does any are phones allowed?
Yeah, well, they could use it.
I think a calculator like this one could be quicker.
I got
You
it.
do it, not me.
I'm locked.
Should we try it again?
Oh, you can do it on. Oh, okay, cool. Yeah, let's okay, guys. New three-digit numbers. If this doesn't work, we'll just pretend they're out. Okay, whenever you're ready.
So nice and loud and quick,
Yeah.
right?
Yeah, the speed was okay. The speed was fine.
Okay.
Yeah.
Okay. Okay, so start filming.
632.
132. 123.
729. 300. 655.
534.
211. 822.
513.
Wait, sorry. Sorry. That was my bad. I messed up.
Oh, are we resetting? Okay, reset.
Yeah.
I didn't even start doing it.
Wait, can I like?
I was.
No, it's fine. We can do it again. It's fine. We can do it again.
How can we help?
Like sometimes I'm asking too much. Like sometimes like after a number, immediate another number, I don't hear like the hundreds and whatever. So I if it's like 123, 500, then I just do 1,235, which is my bad. But
So let's take like a 1 second pause. And then
or a half second pause.
Half
Yeah.
second
Okay.
pause.
Guys, I'm not
Okay,
a.
reset.
I
No
was
problem. This is-
zooming.
You're doing great.
You were pretty fast.
Okay. Whenever you're ready.
632.
754.
153.
Sorry, what?
123.
214.
584. 673.
632.
524. 272.
653.
412.
100.
110. 678.
Is that it?
Yeah.
Oh, 6361.
Yeah.
I know you always do the 100, and like I get so thrown off by the 100. I don't know why.
My bad.
So
No,
I was
it's not your
thinking-
fault. Like
I was
like,
picking an easy number because I
and
was
like
typing on the other.
in like exams, they'll always give you like so many like impossible numbers, and then there will always be that one number that's like 12, and then I'll just be like what. But yeah, so can I borrow a piece of paper?
Sure.
I couldn't find like my past worksheets, but yeah, I had to do a packet of worksheets every week as a kid. But most of them would just be like, so most of them would be like this, and like pages and pages of this. All of them would be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there would be a few minuses like that. Let's not do that much. Let's do a plus there. Let's do a minus there and a minus there. So it would just be pages and pages of this. And I just had to do them. And So for homework, if I got them all right, I got a good, I got a check mark. But if I finished a page in class time, which would usually take like, let's just say, so there would be 10 problems per page, and you get 2 minutes each problem, so 20 minutes. And if I got them all right, like nothing wrong, then I got a penny. And I have many pennies, which is pretty nice. So for these problems, like these are the most standard of exams. You start, you do like the numbers behind the decimals first, and then you carry over whatever you get, and then you add those.
Does it do well with negative numbers or no?
No, not really, because let's just say I want to do 63, you say 63, right? And then the next person says negative 68. So then you would have to clear your 23, and then you have to put in the 68, and then you have to minus 23, and you have to remember this is the negative 45. So it doesn't work that well when there's a lot of numbers, but if it's just 3 numbers, it's fine. But in standard exams, they rarely ask for negative numbers because the B's weren't made for that. But yeah, so like for example for this, I just do, this is my ones place, so I would start my tenths and my hundredths, so 14, 72, 10, 89, minus 12, wait, I'm sorry, 14, 72, 10, 89, minus 12, 77, 83, 15, 76, minus 12. So then I get 8, 2 here, and then I can just move over to 3 here. So then I have a 3 starting off, and then I'll just do 289 plus 579 plus 381 plus 120 minus 729 plus 777 111 minus 150 837 minus 10. So then I get 2208. Oh, my handwriting sucks. Okay, so yeah, that was pretty much it. And what else do I want to say? Oh, like doing pages and pages of these every week, and each page is like 10 problems of this, kind of gave me like OCD, and I would always have to check each problem like 5 times because I really wanted that penny. But yeah, it was pretty fun as a kid, especially the pennies. So once you're good with this, oh, they're still calculating. I can do it again. So like once you're good with this, you translate this into your mind. And that sounds weird, but you basically just visualize everything in your mind. So I guess you get like muscle memory, but it's in your mind. And they call it the AMC, the abacus-based mental calculation. It's also just called mental arithmetic. Yeah, that's right. So just like imagine all these beads, all this formation, and you pop in your mind. Also guys, I talked about this for one of my college videos, and I got into the school. So it was pretty helpful, honestly. Yeah, so you put this in your mind, and so basically when you add or subtract stuff, you just visualize beads. You can like multiply and divide. I only practiced that for like a few years, but it wasn't useful in real life, so I don't really practice that anymore. But if you do like a quick like 3 times 752, I just get 2,356.
Yeah.
But
And you had abacus
yeah,
in your
so
mind?
like when you start off visualizing, you do like this weird thing where you use these 2 fingers.
Mhm.
So you're just kind of doing this. So it's just 3 times 752 is 21, 15, 6. So 2,256.
Mhm.
You guys can't see anything because it's on your head, but that is like the whole thing. So like, if I was to add, I would just say like random numbers and someone get a calculator. Okay, are you ready?
Yeah.
So like 14 plus 72 plus 86 plus 100 plus 274 plus 546 minus 10 plus 80 plus 16, that's 1,178.
Yeah.
And that is all I did. Like this to me is a 1178. Like sometimes it gets really hard too, and especially in the beginning, because you think like, oh, like I'm gonna put my thumb here, that's 1. I'm gonna do this, that's 1. And then like you come back a few seconds later, you forget, is this a 1 or is this a 2? Because like this is all arbitrary. Like for some people this could be a 3, but for me this is a 1. If you have small hands, this could be like 4, but it's just, so like what happens is this is your 1, you do this, and then you translate it into your mind, and that's a 1. If this is a 7 on your, this is a 7D, which is, let's just do a 76, 78. So this is the 7, and this is an 8. So that's what you're doing in your head, and once you get good enough, you kind of like, you don't use your fingers anymore. I mean, you could, it doesn't matter, it's just people would think, like, what are you doing, like, doing this? But, like, if I wanna do, like, 458, so this would be 458, yeah,
Yeah.
as expected. So, if you guys wanna, I'm not that great of 3-digit numbers, but if you guys wanna like think of, how many people in your class? 14?
14.
So adding use 15. If you guys wanna think of like 2-digit numbers, and then go around and say them out loud. You can be a bit quicker just because these are 2-digit numbers, but if you're too quick, then I'll lose track.
So are you gonna add these together? Just kind of mental, okay.
I'll add these together.
Okay.
Okay, it's 2-digit numbers.
In 8th grade, when I was doing this on Zoom, we had everyone like enter something in the chat box, which was very, very reminiscent of Zoom. But yeah. Okay, whenever you guys are ready.
Starting with Dylan.
2-digit numbers?
Yeah.
14.
31,
Sorry, I'm so sorry. Okay, can we start again?
14.
31, 52,
63. 17. 27.
28.
76. 87.
92.
Oh, okay,
I always
92
forget
was
your part
yours.
of it, sorry. 23.
Okay,
50.
11. 19.
590.
Yeah.
If you guys saw, I was like kind of tapping my thigh, but my teacher, well, she doesn't teach anymore, she's retired now, but I haven't like been a TA for like a year or so, but back when I was a TA, she did not like it when I would do this physically, because she wanted to show like the other kids, like, look, she does it in your head, so I just secretly do it underneath on my thigh, but I don't do like that much, like, I just like tap it sometimes to like remind me where the 5 is or something, but yeah. Do we wanna go again, or?
Can we all give you 1 digit and you multiply them? Like we all
15
give her a
digits?
1-digit number.
Oh.
And they just give you what?
Yeah, I think that would take more time, but I think I could do, so it's like, for example, like 7 times 8, and then times like 9, and then times like 3. Huh. I'll let you know when I get off track, but I have a, I'm not confident I would work, but I'm up to try it.
So a little bit slower than
I
that.
did not do that.
Sure.
I apologize.
I'll like stop if I start losing track of numbers.
Okay.
So like 1-digit numbers, I guess.
5.
8, 7,
6.
Wait, 5, 8. Can we not do 5s?
Okay.
Sorry.
4.
6, 2,
3. 9. Two.
Hold up. Okay, I finished with the first row.
Okay.
9. 2.
7.
Wait.
Wait. Never mind. I lost
This is
track.
hard, yeah.
Yeah, I got up to 9, which was 1296. And then what was the one after 9?
2.
7.
After 2, it's 2592. Yeah. I don't think this is gonna work. But
Okay.
1, 2, 3, 4,
Yeah,
5,
that's too
6,
many,
7.
and it's
I
already
did
billions.
half the class.
That's billions.
Yeah, because like once you like if you just do 2 alone, after a few you get into the millions. But-
Yeah.
Okay, I got half the class though.
Yeah, that's great.
And usually like if you want to do like minus, you usually minus numbers that are less than the sum you already have. Because again, you don't work with negative numbers. But yeah.
That's all.
Great.
That takes what we're
Do you know how to use it? I thought you were learning how to use the abacus.
I was I learned. I used to live in Japan, and I took a class for adults, and I struggled very much. And there was a group of us, maybe 30 adults, and they had a competition against 6-year-old kids, and we lost really bad. Like none of us knew what was going on. And these kids, like once you have it, like you say, and it's a very, very powerful just calculation tool. And I thought I'd learn it again, but I don't have a proper teacher, and I'm a little bit lazy, and I have to grade papers and things like that. But it's on the agenda.
Yeah. And this is pretty helpful for like the SAT or something. But I will say in like actual like other maths, I realize that this sometimes poses a problem because I feel like I can do everything in my head. It's like I won't show enough work or something.
see.
But
That's
but yeah, it's been pretty cool.
Sabrina, thank you so much for
Of
sharing with
course.
us. Ladies and gentlemen, please give it up. Sabrina here. Some really special skills, so thank you for sharing
Thank
with
you.
us. On your way out, no more Sabrina.
Yeah, this is my last math class actually.
Yeah. Wow.
Um,
You're always welcome to come back and visit, though.
yes.
So, well, I'll be here. I'm gonna turn this off.